Hi friends, welcome back to our channel. Today in this video we are going to learn about window functions in MySQL. Okay, basically window functions allows you to perform calculations across rows of data without grouping the rows. This means that you can do things like calculate running totals, rank items, and compare current rows with previous or future values, all while still seeing each row of data. Window functions do not collapse rows like normal aggregate functions, example sum average. They work on a window of rows defined by you. Let's see how window functions work. So the structure of window functions looks like this. Function over partition by column order by any column, close the bracket. So this is the typical syntax of window functions. We'll see with examples. So here partition by groups the data, order by specifies the order in which rows should be processed. Okay, let's see with some examples. So first example, get row number for each customer orders. So in this table we are going to use these three tables: orders, order detail, and customers. Okay, so we have the orders table, order details table, and customers table. We'll use these three tables to understand the window functions. If I go here, we need to get a row number for each customer order. Select customer ID, order ID, order date. So now we are using one window function row number, row underscore number. So this, as per the syntax, we have to first give the function followed by over partition by customer ID, order by order date. So we name it as a row ID. So from which table? From orders. Let me run this query and see the output. So if you see here, we have the row number for each customer. So for customer 1 has placed 2 orders, so we have 1 and 2, and the remaining 3, 4, 5 customers placed only 1 order, so there is only one row number. We got the row number for each customer ID. So what's happening here is, here row number gives a unique number to each row within a group. In this case, each customer. So we are saying partition by customer ID. So this will be one group. Each customer will be a group, and for each customer we are getting a unique number to the each row in that particular group of customers. And order by sorts the data based on the date. Okay, so this order has been placed first, so that's why we are getting row number 1, and this order is placed next of second order placed by the customer ID 1, so we got the 2. Example 2, get running total of sales for each customer. So we need to get the running total for we need to calculate running total for the amount each customer has spent. Okay, we will use the orders and order detail tables. So as I have shown you before, we have orders, order detail and the customers table. So for this requirement we will use orders and order detail table. O dot customer ID comma O dot order ID comma sum of OD, here OD for order details table, OD dot selling price into OD dot quantity as order total. So this is the total amount for each order, selling price into quantity. Next we will get sum of OD dot selling price into OD dot quantity. So this is the calculation to get the order total. Next we are adding one more aggregate function, that is sum. As per the syntax of window functions, we need to first provide the function and then followed by over. In the over we have to provide partition by order by. Sum of over partition by. Partition by is nothing but grouping something, so we need to group by customer ID. For each customer we need to get the running total, so that's why we are providing partition by O dot customer ID order by O dot order ID as, let's call this one as the running total. Okay, we call this one as a running total. From orders O join order detail OD on O dot order ID is equal to OD dot order ID. We are joining these two tables on the order ID. Group by O dot customer ID comma O dot order ID. Okay, let me run this query. So why we have joined these two tables? Because to get the quantity and selling price of the orders. Okay, so we have that information in the orders table. So if you see here, we have the running total for each customer. So only customer 1 has placed 2 orders, so running total is nothing but we need to partition by the customer. Each customer we need to get it, so we are doing the partition by customer ID, so that we get, so this 3800 at the running total is the sum of 9500 plus 28500, which gives us 38000. Okay, this is how we find the running sum of sales, running total of sales for each customer. So the next example is ranking orders by date. Rank orders by date. So let's rank the orders placed by each customer based on when they were made. This is useful when you want to see which order was placed first or second. Okay, let's write the query. Select customer ID, order ID, order date, comma. Now as per the syntax of window functions, first we have to provide any function. We are going to use rank function here. Rank over partition by customer ID. We need to get it, if you want to get it by each customer ID, we can write partition by customer ID, order by order date as order rank from orders table. Okay, So let me run this query and see the results. So this is like ranking based on the order date, because we sorted the data based on the order date. So we have the order, we have used we have learned how to use rank function in this example. So that is the main use case here. So we are going to use one more function called a lag function. So lead or lag function. So the query is compare an order to the previous order. Write the query, select customer ID, order date, order ID, next order date, comma. Now here I am going to add lag, order date, comma 1. This is how we can use lag function. So we have provided the function, and then we need to add over partition by customer underscore ID, order by order date. So this partition by order by is not mandatory, it depends on your requirement. You can provide as previous order date. So from orders table. Okay, let me run this query. After that I will explain. So here we can see the previous order. Only customer 1 has placed 2 orders and we want to get the previous order column. So only customer 1 has the previous order. So here we are fetching the previous record from this order table. So we have provided order date here. Order date in the lag function. Inside the lag function we have provided order date. So on comma 1. So 1 means it will fetch the previous record. So here lag of order date 1 comma looks at the order date of the previous order. Partition by customer ID ensures that we compare previous orders within each customer group. So it is not fetching a previous record for entire table. We are grouping the data by the customer ID. So that's why we are getting nulls for the next customer. Okay, if you don't provide partition by here, let's see the output. You will get the previous date irrespective of the customer. If I run this one here, you will see only the first record will be null because there is no previous record. So here we did not group the data, instead we just said order by the order date. So all the records in this table are sorted based on the order date. Okay, and then we fetch the previous record, previous order date in the new column at the current row. Next we will see the lead function. So the example we are going to use is find the next order date. So we have used lag function to get the previous record. We use lead function to get the next order date, similar to the lag function. Let me copy this query and paste it here. So instead of lag we can simply say lead. Okay, lead, and run the query. So if you see here, the last record is null because there is no previous next record. So what we are fetching here is, this is the order date. Okay, this is the order date, and we are fetching the next order date into the new column of previous order date. Instead of previous, we will name it as next order date. And we are not partitioning by the customer ID, so it's just picking the entire table sorted on the order date, and we are fetching the data. Okay, if you want to group based on the each customer, then you have to say partition by customer ID. Let me execute. Only customer 1 has placed the 2 orders, so it's fetching the next order from the orders date, and all other records are null because there is no next order for each customer. Average of previous 2 orders. Okay, we'll get moving average from the previous 2 orders. Okay, let's write the query with order underscore totals. So this is a common table expression. We are naming it as order underscore tables as select o dot customer id, o dot order id. Here o refers to the orders table, sum od refers to the orders details table, selling underscore price into od dot quantity as total sales. So this is the total sales from orders o join orders order detail table od on o dot order id is equal to od dot order id, and then we group by customer id, o dot customer id, o dot order id. Let me close the bracket. So here we have just grouped the data. So we have an error here. So we have an error saying that od dot selling price is not there in the table. Let's see the table columns in the order detail. So we have selling price, od dot, sorry, here the spelling error, so price. Okay, let's run this query one more time. Okay, success. Now here we have the customer id, order id, and the total sales. Okay, let's go back and write the next part of the code. So next we'll write select customer id, order id, total sales, comma, average of total sales. As for the syntax, first we have to provide the function over, next we'll identify, we'll say group by, or we need to create buckets based on what. So partition by customer id, order by order id. So this is not the end. Here we are going to write rows between. I'll explain what this rows between will do. Rows between two preceding and current row as moving average. So here rows between two and preceding and current row. This looks at the current row and the two preceding rows to calculate the average. Okay, this average will be calculated by looking at the two previous records from the current row. So in that scenarios we can use rows between two preceding and current row as moving average from, so from order underscore totals. So let me execute the query to see the output. So if you see the output here, we have the customer id, order id, total sales, and the moving average. So 38,000 divided by 2, 19,000, which is the average. So far we have learned about row function. We have learned about row number assigns a unique number to each row, and the sum can be used to calculate running totals, and the rank function assigns ranks based on certain conditions. Lag function looks at the previous row's values, and the lead function looks at the next row's value. Average function can be used for moving average. Okay, so far we have covered the basic queries. Now we will see the advanced queries. Let's dive into more advanced window functions in SQL. So these functions will help you perform complex data analysis and manipulation tasks, making your queries even more powerful. Okay, We'll continue using those three tables: orders, order detail, and customers table. So in this example we'll see understand. In the previous example we have seen a rows between. We'll see range between. Okay, so range between is based on the value range in the order by class. It looks at the data within a value range rather than specific rows. Okay, so instead of rows it will look for the value range. Let's see with one example. Okay, the example here is rolling total sales for last 7 days. So I will copy the previous CT that we have created, copy this one and paste. Okay, now we have the order totals common table expression created. Select customer ID, order ID, order date, comma, total sales, sum of total sales over partition by customer ID, order by order date, range between interval 7-day preceding and current row as rolling 7-day sales from order totals. Okay, let's run this query. So no need to provide comma here. So we have an error saying that unknown column order date. So we don't have order date. So let me add in the city o.order date. Let's run the query again. Okay, now we have the rolling 7-day sales. So let's see one more advanced example. Percentile calculations using percent underscore rank. We will calculate the percentile rank of each customer based on their total spending, with the higher spenders getting higher rank. Okay, based on the percentage of spend we will rank the customers. So let me write the query with customer totals as select o.customer ID, sum of od dot, here od refers to the orders table, selling price into od dot quantity as total spend from orders O join order detail od on o dot order id is equal to od dot order id group by o dot customer id. Okay, next select, so that is the CTE. Now select customer ID, total spent, and then we will write the window function here, percent underscore rank, percent underscore rank. So function we have mentioned, next over order by total spent. So we are not partitioning here by the customer ID because only we have data at the customer ID level. So we don't have to group the data. Already we have the only one record for each customer as percentile rank from customers totals. Let me run this query. So before running I will explain. Here percent rank computes the percentile rank of each customer's total spending. Order by total spent ranks the customer based on their total spending from lowest to the highest. So we sort the data based on the total spent value. So this is the percentile rank based for the each customer. Divides your data into specific number of equally sized groups, we can say buckets. So this is useful when you want to split data into quartiles, deciles, or any other percentile group. Okay, for example, divide customers into four spending, let's say two spending buckets for your easy understanding, two spending buckets. So I will copy the previous query. Now we will modify this percentage rank to n-tile bracket provide to over order by total spent as spending. So let me execute this query. You see here we have created two buckets of information based on the total spent. Okay, we have one more function called cumulative distribution. So this function calculates the cumulative distribution of the value. It tells you the proportion of rows that are less than or equal to the current row. Okay, next example we are going to talk about is cumulative distribution. For example, find cumulative distribution of total spending. So we can calculate how many customers have spent same amount or less than the current customer. Okay, so I will use the same previous query. I have pasted the same query, and let's modify the query here. So the window function is cumulative underscore dast over order by total spent, as we name it as cumulative distribution, and let's execute this query. So based on the value range of total spent, we got the cumulative distribution. Let's see one example to find the moving average over last three orders. Moving average over last three orders. So I'll copy and paste the previous queries. Okay, so here in this table we will modify to get the moving average over last 3 orders. Simply we have to say, instead of this one, we'll write average total sales over partition by customer ID, order by order date, order ID, sorry, and rows between 3 preceding and current row as moving average last 3 orders from orders table. So similar kind of examples we have already seen, but this is one more scenario where you can find the moving average over last 3 orders. Okay, let me execute the query. So we got the results. Rank customers by order count within each country. So let me paste the previous query and I will modify. So instead of order ID, we want the country column from the country customers table. So let's say c dot customer ID and c dot country. I will call this CT as customer underscore order underscore count. We need count of o dot order ID, so we can call it as order count. From orders customers table, C join orders table O on C dot customer ID is equal to O dot customer ID group by C dot customer ID and C dot country. So here we get the order count by the customer and the country. Next we write select customer ID comma country so we have the order count from this customer order count table and we don't need the total sales. So now we'll write the window function to rank over partition by country order by order count. So if we want specifically sort, we can mention descending order as country underscore rank. So from customer order count table, okay, let me execute this one. So here we have the country rank based on the order count within each country. Next we will write one more query to get the running total and rank. So we have to get the running total along with the rank. Running total along with the rank. So I will reuse the previous query here. We need the total spent Okay, let me, so here we have the total spent. Okay, I copied and I paste it here. So let's modify this window calculation. We want the running total, sum of total spent over order by total spent as running total, comma, rank over order by total spent, the descending order as spending rank from customer totals table. Let me execute this query. So we have the running total and the spending rank for each customer. So here rank over order by total spent in the descending order ranks the customer based on their total spending. We are specifically mentioning here descending order because we want to get the highest value uh, to get the rank 1. Okay, so it is mandatory to sort this data in the descending order. If you don't provide any um, don't specify the descending order or ascending order, then you will get the different results. If I run this query here, you can see the lowest value is rank 1. So if you specifically want highest value to be ranked 1, you have to mention in the descending order. I think these examples have given you a solid foundation for working with Windows functions in advanced scenarios. If you like this video, please hit the like button and do subscribe to my channel. Thank you for watching.